Guys and girls, it's Noah time!
So guys, type 3. You learn type 1, type 2, it's pretty easy stuff. Really, it's all the same thing, just use log here and there. Very nice, very simple. Type 3 is probably the most challenging type. A lot of people will get this type and they will play the guessing game. Type 3, there's a lot of variations to type 3. I can't give you all the keywords, but you get the idea. Type 3, keywords. Again, every question you read, look for keywords and use the formula. Bam, keyword, bam, formula. This one talks about growth. Okay. Talks about decay. Talks about half-life. Not a video game. Not the Counter-Strike theme. Half-life. It talks about, and there's a bit more, but these are the key. I'm going to explain to you what half-life is later. Formula. Your formula for type 3 really is this. A equals to P. Just again, same formula. R to the power of T over N. Okay. Same concept, same logic. A is accumulated, or your final value, whatever you want to call it. That's bad. A is your accumulated value. Accumulated value. Okay. P is your principal. Same concept. Okay. Only difference is we're not necessarily dealing with money this time. R. Here is where the first trouble comes in. I'm going to put a star beside R. R is basically is your rate. I'm going to write a few things down right now because a lot of people have trouble with R. I'm going to give you an example. If I say the word doubles, R equals to 2. By logic, because double means 2. If I say R equals to triples, right off the bat, we know R equals to 3. Okay, there's no twist, no tricks, no nothing. Keep it simple. Now, there's one word in there that's probably new to you, and if you've taken biology, you would know what a half-life is. I'm going to teach you what half-life is. Half-life. Half-life is the amount of time it takes something to decay to 50% of its original value.
Is that it's supposed to be there?
What? Something, it takes something to decay to where?
What time?
Amount of time. Nope, never mind. It takes something to decay to of its original value. Now, half-life is mostly used in medicine. Every hospital in BC, in the world, has a pharmacy lab. There are special medications that once they make it, it breaks down so fast that if you don't get it to the patient in time, you got to start again. That's why it's called the half-life decay. Every unique element has a half-life. It breaks down over and over again. So hospitals has a pharmacy lab. Now, they make a medicine. Sometimes half-life is 10 minutes. If they don't get from one end of the hospital to the next end of the hospital within 10 minutes, the drug doesn't work anymore because it decays so fast that it's gone. So hospitals came up with a unique way to go from one end of the building to another end of the building in less than 1 minute.
The tubes, right?
The tubes. If you go to Costco, how many of you been to Costco? Every Costco has those money tubes. They wrap up money into this little container, they put it in, and the tube sucks it up. and it all goes into a secret vault. And there's a guy in there that collects and counts the money. So I thought of a great way to be a heist one day. Redirect those tubes to my house. Just sit there and no one thought about robbing Costco, but I did. I thought about that in my spare time. So one day I'm going to go to Costco midnight, just redirect those tubes to my house. And I just sit back and watch these tubes shoot down. Okay?
But since you told the whole class, I gotta split this.
Oh yeah. Now I split it. So hospitals, every hospital has underground tubes. You don't see it. It can be underground or ceiling. Once they make it in pharmacy, they put in this tube. The tube sucks it up and shoots it all over the place, and it goes to wherever it wants to go. And it can get there in less than a minute. And then they get the medicine to the person. That's called half-life. Everything has a half-life, especially plutonium. How many heard of plutonium before? It's plutonium, uranium. It's one of the things that's used in nuclear weapons. Right now, Iran, it's all over the news, is supposedly trying to make a nuclear weapon. And the rest of the world is against this. And they're trying to make nuclear weapons. They need plutonium. And they need uranium. So they're digging deep into Earth to collect these elements. But the thing is, they only have a certain amount of time to work on it before it degrades. And I'll go over in this math question with you. So guys, half-life amount of time takes something to decay. So N, another issue with N is this. I'm going to write down N. It's going to be confusing the first time you hear it, but it makes sense later. N stands for this: every, per, or half-life. Sounds confusing, but I'll explain to you what it is. Every, comma, per, comma, half-life. It's my own special definition of N. Okay? Every, per, or half-life. You'll see it when the time comes. Now, I'm going to make another star. In all half-life questions, R will always be, there was no exception to this rule, will always be blank. In every half-life question, R will always be blank. Aaron, what is R? What's the value of R in every half-life question? Nope. Close. Half. Because half-life means something to decay to 50%. So in all half-life questions, it surprises me when I have students write exams, they see a half-life question and they don't know what R is. Because R is your rate. It decays is always 0.5. Remember this. If you see a half-life question, R right off the bat is 0.5. There's no exceptions to this rule whatsoever. In all half-life questions, R will always be 0.5. I'm going to give you a question. Yep, that's half-life. 1/2. Try this question. Canada's population, I was reading the news this morning, Canada's population, I believe, is at 33.5 million. Wow, you read the same news I did.
Surrey is the fastest growing city in Vancouver area.
Canada's population. You know the whole stats. You should be a real estate agent, Jasmeet. Okay, Canada's population, as of today, is 33.5 million. Kid you not, 33.5. As of today, right now, we stand at 33.5. India, 1 point something billion. Okay? So, you think we're little, we think we're a lot. Guys, India, for every one of you, there's 30 people like that in India. So, India's population is 30 times more dense. China is 1 point something billion. That's why in China, there's a one-child policy or two-child, something like that. One child. Come on. I'm not Chinese. So Canada's population is 30. It doubles. Okay. I'm going to say it doubles every 22 years. Okay, I'm going to make it up. What will the population be like? What will the population be in 2037? 2037. Let's say that's the year I'm going to retire. That's the year I'm allowed to retire. What will Canada's population be? For keywords, this question talks about population. It talks about doubles. Okay, so we no longer, it can't be earthquake, it can't be type 1, there's no money involved. So this is type 3, right off the bat. I go A equals to P R T over N.
Mr. No, for your tests, are you gonna, like, there's gonna be 1 mark for the writing the formula down?
Oh, 1 mark, please. This is not charity. Please. What kind of charity is it? CP 33.5. Notice I didn't use all those zeros because there's no point in adding all those zeros because I know I'm going to work with millions, so there's no point in adding a bunch of zeros to it. R. Okay, keep it simple. Grumpy, what's R? Whoa, 0 point, please. What's R? 2. Because it talks about double. Double means 2. Simple as that. T.
But it says half.
No. Half-life. Is this a half-life question? No, it's not. T is, right now we're in 2012. 2037. Do the math. 25. Now, here's the next question. What the heck is N? See, N, we look for keywords. I mentioned to you N is every, per, or half-life. And I look at, there's one word in there that stands out. Hey, look, there's that word every. So every refers to N. Now, sometimes you have another English word similar to every, each. It's the same concept. Each 22 years. So N is that's your N value, 22. Plug it in. Okay. And again, follow BEDMAS. 22 to the power of 25 divided by 22 times 33.5. 73.64 million. So when I retire, our population will be at 73.64 million. 73 million. That will be in 25 years from now. Okay. So that's our population. Next question. We want to compete with India and China. How long will it take you to reach 100 million? When will the population?
Where did you get 2 from?
2? Because I'm talking about double. Double means R is 2.
In the last one, we also used 2.
And the last one?
Compound or whatever it was?
No, that's a totally different question. When will the population reach 100 million? Okay. I want to know how many years from now do you have to wait for our population to reach 100 million? I'm going to pause it, let you try this one. So I'm hearing the answer of 34. I don't know who's right yet, so let's do this slowly. See, my final value I know has to be 100 million. So I'm just going to use 100. Forget about all the other zeros. 33.5, everything stays the same. This will be T over 22, because I'm solving for time. Take a minute, and here's a mistake I know a lot of students will make. They're going to multiply 33.5 by 2. Do not do that. You're going to get this wrong. Do not say, you have to move the 33.5 over. Okay? You can't multiply with that 2. A lot of you will try to do that on exam. So again, you go 100 divided by 33.5. 2.985. I'm going to use that many spaces, so it'll be 2.985 equals to 2 T over 22. Guys and gals, go ahead and log both sides right now. Because really, this is all hidden rules. We're just practicing over and over again. Log 2.985 equals to T over 22 log 2. Oop, log 2. So I'm going to do this nice and slow because a lot of you are going to get confused here. I'm going to bring log 2 over first by dividing by log 2. Okay, just nice and slow. Keep it simple. Log 2.985 over log 2. I want you to actually get a number for this right now before you do anything else. Okay, so I'm going to do this with you. Clear all this up.
1.57.
Does it say 27 or was it
Log 2.985 divided by log 2, 1.5777.
1.57.
does that say log 27?
No, log 2, right here. No, this is just log 2. So guys, gals, but now we're getting t, so you got to bring the 22 over, and we got to multiply that by 22, so go times 22. 34.71 years. So in 34.71 years from now,
How do you know how many decimal places to keep?
surprise me, it'll be in 2040, roughly 2047. In 2047, our population will reach 100 million. So my answer is t equals to 34.71 years from now. Guys and gals, that's called type 3. But type 3, it's like I said, you need more practice. I'm going to give you another type, more examples with type 3. Try this one. Plutonium has a half-life of 30 minutes. You have 300 grams of plutonium. Plutonium. How many grams are left after 4 hours? Plutonium has a half-life of 30 minutes. You have 300 grams of plutonium, so which means every half an hour it decays to 50%, 50%, 50%. I know you can probably do a calculation on this using a simple spreadsheet, but try to use a mathematical formula for this. There's a twist to this problem. I'm going to pause it. If you're stuck right off the bat, let's just write down my formula. I know this is type 3. A equals to PRT over N. My initial is 300. That's my initial. My R value. Kavir, what's R? No. Let's go back to my notes right here. 0.5, yes. It says, let's say here, in all half-life questions, R will be 0.5. The moment you see a half-life, just go in 0.5 right off the bat. T is 4. Now, what the heck is N? 0.5. Because N, some of you will want to put 30, but really N is 0.5. Guys, gals, T is 4. Solve it for me, and I'm going to pause it. See, my T value is 4 hours. That's T. Remember, N is your half-life. Would you agree they mentioned the half-life of 30 minutes? So that's N. N is half-life, which is 30 minutes. But because I'm working with hours and minutes, you have to convert minutes into hours, so which is 0.5. So this basically becomes 300 times 0.5 to the power of 8. Again, just keep it simple. Clear. 0.5 to the power of 8 times 300.
1.17.
In exactly 4 hours, there's only 1.17 gram of plutonium left because it decays such a fast rate. 1.17 grams. So if you start with 300 and you don't use it up in 4 hours, you only have this much left. So that's why everything has to be speed fast.
Would you take Mark's stuff if we would have missed the minutes?
Nope. Try this next one. There's actually a substance more precious than plutonium. Nope, more precious and more powerful. There's a substance called Ng. Noeum. One of the toughest and the rarest element, most precious on Earth. Ng, it's called noeum, decays to 22% in 3 minutes. Find the half-life. So this unknown substance, noeum, so precious and rare, if you don't use it up, it's done, it's gone. Find the half-life. Guys, gals, I'm going to pause it and let you try this. So if I look at this one, it's asking you for half-life. So I know my formula is going to be A equals to P R T over N. Now, I'm going to look at each number one by one. 22% is the first one. Okay. Monica, is that my A or is that my P? 22%. Nope. A. Because it's your final value. So let's go 22 right now. Equals to P. I know my R right off the bat. R, Bikram, what's R? 0.5. I don't even have to think about it. If you think about it, it means you don't know what you're doing. You could. It's up to you. How you want to do this. Now, the question is, what am I solving for? T or N? You're solving for N. Because N, remember, go back to my notes. N is crucial. N is every, per, or half-life. The half-life value is N. So, if the half-life value is N, this purple value must be T. So let's write down 3 over N. The problem with this is I'm still missing a P value. Think about 100%. Because if you decay to 22%, your original has to be 100%. That's the logic to this. So the P is actually there, but it's hidden. So let's go fill this in now. 22 equals to 100. If you decide to use the decimal system, P would be at 1. That's 0.53 over N. Guys and gals, I'm going to pause it again and let you try this on your own. So guys and gals, first thing we're going to do, let's move this 100 over. So you have 0.22 equals to 0.53 over N. Let's log both sides right now. Log 0.22 equals to 3 over N log 0.5. Okay, bring your log over. And again, I like to do it nice and slow for everyone to see. Log 0.22 over log 0.5. And let's just plug it in slowly.
You get 2
Log 0.5. Whoa. 2.18. So 3 over N equals to 2.18. But the problem is this. We didn't solve for N yet. How do you solve for N from here? Cross multiply. Okay. So if you cross multiply, watch what we're going to do. Be 3 equals to 2.18 N. And then I can finally move this 2.18 over. So N equals to 3 divided by 2.18. Okay. And just go ahead, 3 divided by 2.18. Bada bing, bada boom. 1.37 minutes. So this element can reduce to 50% of its original value in 1.37 minutes. Question?
So I was saying where it says 3n equals log 0.22 over log 0.5.
Yep.
You can just put a fraction of
You could, and you get the same answer, I believe. Right? Yeah. Question?
Instead of like starting, can you just put half as your cumulative value, which would equal the principal of 1, multiply by the rate of 0.22, and then over that, then like put 3 as your n, and then leave your time open. So
Would you get the same answer?
I got some answer, but
Yeah, it's fine. If it's the same thing, it's a different way of working it, but it should be fine. Guys, here's your Supernova Challenge question for today. Good luck. Let's see how many you earned this cards today.
You never did the perfect for yesterday.
Oh, I'm going to call you out one by one soon. Well, once you do your work. Here is your question. What? Oh, you're not done yet. Supernova question for today. Good luck. Light decreases by 2.5% for every meter, because every meter it travels through the ocean. One of my goals, when I was younger, your age, 2 years ago, I've always wanted to go diving. Because I was watching those movies, and it looks like when you dive down there, everything is so blue and clear. But in reality, when you dive, you can't see anything. It's dark and cold. So those movies doesn't work. Okay. So every time I see those movies, I have always wanted to go diving because wow, it's like another world. You see the bright light and everything. But in reality, if you jump off the ocean in the middle of a beach somewhere, and you try to look in the water, the only thing is nothing because it's dark, pitch black. Because their light shuts down for every meter it travels through the water. Your question is this: what percent remains at 11.4 meter? Good luck. Show me full work. This is a type 3 question. We're going to use this formula. A equals to P R T over N. Now, I'm talking about light intensity. I didn't mention anything about P or anything, so let's use 100, because that has to be, at the beginning, light is pure. Okay? No, we always assume everything starts at 100%. If I mention percent, the R value is what's killing people. Majority of you walked around and says 0.025. That's where majority of you went wrong. I want you to highlight this word, decrease by 2.5%. If you decrease by 2.5%, it's not 0.025. What should the right number there be? 0.975. Because if you think about this, 1 is like you're neither increasing or decreasing. But if you drop by 2.5%, 1 minus because decrease by means you're dropping. That's how much you're dropping by from where you're starting from. 0.025. Okay? Now, that's where the key point is right here. I want you to highlight this area. This is where people are going to make mistakes, so don't fall for that. My T value is right here. That's my T. 11.4. But what is N? 1. Because it says again, like I said, the key word. I look for keywords, every, per, each. They all mean the exact same thing. 1. Go ahead, plug in right now, and let's solve this.
Wait, how was someone close?
Robert had 0.75, but he didn't really see that was 2.5 because he did 25%. That's where. And then Bikram got it, but let's give him 2 tries. So guys, watch me. We're going to do 0.975 to the power of 11.4 times 100. So 74.9%. If I go 11.4 meters into the ocean, only about 75% of light will remain. The deeper I go, there's less light until there's nothing. So which is 74.9%. Question like this will be on the exam. You got to be careful. If I say decrease, know what it means. If I say increase, you're no longer subtracting, you're adding by. Because the key word here is decrease by. Highlight this word, please. Decrease by. That changes the whole question. You got to be careful about that. One more type and we're done. And this type is your last one. Then I'm going to assign you your homework question for today. Type 4. Type 4 is actually one of my favorite types. To understand type 4, you need to know one key term. Type 4, there's a number, pi. We know, back in the good days, Megan, what's the value of pi? 3 point. Does anyone know what's the next number after 3 point without using their calculator? 1592, so on. There's actually people, there's a genius who can remember pi up to 2,000 decimal places within 2 hours, I think. Okay? He has a special disease or illness. What happened was that when he was young, he had epilepsy, and he started twitching, and somehow he went home, and his brain started rewired, and he can memorize everything. And he was a math genius after that. And he was on David Letterman. Okay? And he's actually the smartest people on this earth right now. The problem is...
Is it Indian?
Huh?
Is it Indian?
No. Chinese! No, I'm kidding. He's Caucasian. And the problem is, he processes... Kidding. So the problem is, he processes all these things differently from you and I. For example, when we go 1 plus 1, we know that's 2. In his mind, when you go 1 plus 1, he sees shapes. He's like, oh, there's a circle there, and there's a triangle. They fit together. So his brain is done differently. And it happened when he was young. He had a seizure, and somehow it rewired his brain. And the problem is, he can't drive, because every time he drives, there's too much information overload. His brain absorbs everything. He doesn't let go of anything. When you drive, normally you see a stranger walk by, you don't care about it. But when he drives, every little bird that flies by distracts him, because his brain sees everything. And there's a neat video on that, which I'll show you later, which probably tomorrow. And you can actually see his life story of how of a genius he is. And it's if you want to see him teach, I can invite him tomorrow.
He was white.
I can be white. Don't be racist. Now, pi is 3.14159. There's another value, e. A lot of you don't know e. E, grab your calculator right now. This is where TI-83 comes in handy. There's a little button called E right here. Look, grab your TI, look for E, or it says LON, L-N. So you go E, let's just see what E is. Let's go E to the power of 1. 2.71. So let's copy this down. E, the magic number for E really is 2.718. Just like pi, E is another unique number that you never hear about. E, so when we work with logs, we work with different bases. For example, log 3 of 5. The base here is 3. Sometimes the natural base of log is not 10. A lot of you think 10 is a natural base. The natural base of log is actually log E of 5. This is called the natural log. Natural log. Now, instead of writing log base E, mathematicians came up with a new way to work around this. So, for example, they go E to the power of x equals to 10. Normally, we would log both sides, yada, 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 and find x. But here's how it works. If you see E, there's a special way to get rid of E. If you see E, use log has a sister. You guys didn't know that. Her name is Lon. L-N. Log and lon are brothers and sisters. They go hand in hand. Lon only comes, so when you see on your exam that L-N, a lot of you think, same as no, did you spell log wrong? It's actually no, that's just lon. Lon works the same thing. All the rules that work with log, applies to lon. Ln. Okay, so multiplication and all that stuff. For example, e to the power of x equals to 10. Instead of using log, if every time there's an e, you have to use lons. So what we're going to do, we're going to ln both sides. We're going to go ln e to the power of x equals to ln 10. The reason why is this. Ln e always equals to 1. No exceptions. Let's write that down right now. Ln e always equals to 1. That's how we get rid of e. We ln it. So we're going to bring the x to the front. So this becomes x ln e equals to ln 10. Ln e we know is just 1, so it'll be x equals to ln of 10. Punch in your calculator right now. Ln of 10.
Where's the natural log mean?
So ln is right here. Ln. Ln. Hit 10. That's why we use. Anytime you see an e, you got to use ln. So your answer is 2.3. You're going to need that rule. I'm going to show type 4. I may have to finish type 4 tomorrow, but I'm going to introduce it to you, and that's it. Type 4, keywords. I won't have time to do a question, but I'm just going to introduce a formula. That's it. Type 4, keywords. Only one word is key. Compound. Continuously. If you see the word continuously in your question, drop what you're doing. It's type 4, no questions asked. Even if you see the word compound, compound something, the moment the word continuously kicks in, it rules them all. Here's your formula. A. This is the formula people will never forget as long as they live. Once you say this magic word once, you will never forget again. A equals to P-E-K-T. And the magic word is apecte. Apecte. Once you say it, you can never forget again. Apecte. A-P-E. Kete. Okay. Apecte. I'm going to show you how this is used tomorrow. But we don't have time for that now. And I'm going to give you your work for today. Your work! Yep. And tomorrow... So tomorrow you have the whole day. I'm just going to review type 4 and then give you some time to more practice. Let me give you your work first before I go down. Page 40. Number. I advise you to try as many, and there's 1 to 27, but I advise you can do every other question just so you get the hang of. Try a few questions of each type. I'm going to ask you ignore questions that has the word continuously, because you're not ready for that yet. Anything that has the word continuously or E, or if you see a question that has E in it, E to the power something, ignore it for now. I'm going to work with you some more tomorrow. For now, I want you to focus on type 1, 2, and 3. Try random questions here and there so you get the hang of things. Tomorrow we do type 4 and the review, and then you have 4 days or 3 days to study for the exam, and we're going to hit the test fast and hard. Quiz tomorrow, yes. Type 1 to 3.
1, 2, 3?
1 and 3, yep. And that ends our lesson for today.
Wait, 1, 2, 3 or 1?